Hello everybody, this is Pythagorean theorem proof 95. This Pythagorean theorem proof is super interesting because instead of trying to prove the Pythagorean theorem through similarities of triangles or trigonometry, it simply tries to prove the Pythagorean theorem through this simple formula right here. Area of a triangle equals base times height divided by 2. Awesome. So when that triangle is an isosceles right triangle, the base equals the height, meaning that we can substitute h in for b squared for base squared. So a equals base squared divided by 2. Hopefully this will lead to some line c squared divided by 2 equals a squared divided by 2 plus b squared divided by 2. Then we can just multiply a 2 in and get the Pythagorean theorem. Awesome, let's get into it. So this is our triangle here that we're solving for, ACB, and it is inscribed by this circumcircle here, circle O. Now, if we continue BC and you continue at a length of B, you would hit point M right here. Now, because we continued this line a length here, this is an isosceles right triangle, and this is the base. Base times height, which is the same, b squared divided by 2 equals the area here. We already have 1/3 of our Pythagorean theorem found. Awesome. Let's keep it going. If we were to continue this hypotenuse, which bisects down here at A, and continue it down until it intersects with the circumcircle O, we hit point D. Going BD and continuing it out a length of AD, similar to what we did over here, we get point N. Now, point N is also very important because NA is collinear with AC, meaning that line AC is one line. Awesome. Now, other important isosceles right triangles, obviously we have this one and we have this one, but another one that's going to be super important for us today is NCB. This one isn't super obvious, but it is true that line A here is equal to NC. And this NB would be the hypotenuse of that. And similar to how we found the area here, we can find the area of that by saying A times base times height, which is also A squared divided by 2, equals the area. Awesome. So now we have the second third of our Pythagorean theorem. But this last one's going to take some time. All right, so now we're going to try to prove the congruency of MCN and ACB. Now, MCN is highlighted green here, and ACB is highlighted purple, just in case that helps viewing a little bit easier, because it can get a little complicated. Now, we know that side B here, or AC, is equal to MC, because that's how we designed MC, right? So that is already one side that is congruent. Now, we already have an angle here, because they're both 90-degree right triangles, so that is an angle that we have. And lastly, again, this is a little tricky, but look how CB, which is A, is on a isosceles right triangle with CN, meaning that this line is congruent with this line, meaning that that is our second side that is congruent, meaning that we can prove that this triangle is congruent with that triangle. Now, because these two triangles are congruent, we can say that both of their hypotenuses are equal, meaning that AB equals MN, which is why I've colored them both red. Awesome. So, next we're going to look at some altitudes. Now, in this big triangle, M and B here, we see some altitudes. First and foremost, look at the altitude of M coming down, making a nice 90-degree angle, and bisecting at point A. Altitude of N comes out, hits right there at C, bisects A, and then the last one, AB, doesn't go all the way through, and that's for a reason, but also hits at A. That makes A the orthocenter, or the intersection of the three altitudes. Awesome. So, also another thing that's important to note, this larger triangle can be broken, the area at least, can be broken down to the areas of the smaller triangles within it. So NB, MNB, the area is equal to MAN plus MAC plus NCB. Alright, which I have written out here. It's a little bit hard to see, but if you want to pause and zoom in, that's what that's saying. Now, doing some simple algebra, we know that if we took M and B, subtracted from the area of MAN, we would get MAC area plus NCB area, which I wrote down here. Again, pause if you need to see it. Now, that's important because we've already found the area of MCA to be b squared 1/2, and we've already found the area of NCB to be a squared 1/2. Meaning that if we can find what MNB minus MAN is pertaining to C, then we will have the Pythagorean theorem almost solved. Awesome, so let's get into it. Now, because this is the orthocenter and this is an altitude, and this is the base, we can multiply this base by this partial height. I say partial because, like I said, it doesn't go all the way down to the base, just a little bit. So base times the partial height equals a partial area. Now the partial area here is the area of everything excluding MAN. I hope you can see where I'm going with this now. Meaning that AB times NN equals MAC, the area of MAC, plus the area of MCB. All right, and remember that AB is equal to MN because these are two congruent triangles, and remember that C is AB. Now we have C squared, C times C equals this entire area, which we already know here, meaning that that is the Pythagorean theorem, or at least is a Pythagorean identity. To solve it out for real, you would just multiply it to both sides, distribute it in over here, and you would get C squared equals A squared plus B squared. Awesome. Have a great day.